So you are welcome to this presentation, and in this presentation we'll be talking about the radiant heat exchanger, and we'll consider how the first law of thermodynamics is applied in relation to this radiant heat exchanger. This is group 8 chemical engineering thermodynamics project work. So first of all, we talk about heat exchangers. So a heat exchanger is a mechanical device designed to transfer thermal energy enthalpy between two or more fluids, between a solid surface and a fluid, or between solid particulate and a fluid at different temperatures and in thermal contact. So basically, a heat exchanger, as the name implies, is a device that is used to exchange heat. And in exchanging heat, it has to be between two materials or substances, two or more. It can be two or more. So basically, sometimes it's usually between a solid and a fluid. As you all know, a fluid is basically a liquid or a gas, or it can be between two fluids in thermal contact and at different temperatures. So one can be high and the other can be low, so that there will be a temperature difference for heat transfer according to the zeroth law of thermodynamics. Or one can be low and the other can be high, and then heat is transferred from the low one to the high one, which means that there has to be some work applied to do that. So basically, there are usually no external heat and work interactions in a heat exchanger. So in a heat exchanger, everything goes on internally. So as you can see from the figure here, that's just a schematic of a sample heat exchanger. So let's look at the classifications of heat exchangers, or how they are classified. So heat exchangers are classified according to their transfer processes, the modes of heat transfer that particular heat tube exchanger uses. You get it? So as you all know, in heat there are three modes of heat transfer. We have convection, conduction, and radiation. And in this particular video, we'll be looking at the radiant heat exchanger, meaning that the main mode of heat transfer will be radiation in this presentation. So they are classified according to their transfer processes. That's where we can have the radiant heat tube exchanger. They are classified according to the number of fluids involved in the process, the degree of surface compactness, their construction features, flow arrangement, heat transfer mechanisms. So in relation to the construction features, we have various types of heat exchangers. As you can see from the figure here, this is a shell and tube heat exchanger. So looking at how it is constructed, it's like a tube with some shell covering it. So that's why it is named shell and tube heat exchanger. We also have plate heat exchangers. They are constructed in a plate-like form. So that's the classifications of heat exchangers generally. So heat exchangers are designed to transfer heat between two or more fluids, liquid or gases, without mixing them. That's the main thing. The fluids doesn't mix, but heat is exchanged between them. It is commonly used in heating, cooling, and refrigeration systems, as well as in industrial processes like power generation, chemical processing, and automotive cooling. So those are some of the applications of heat exchangers. So they are used in air conditioning systems, refrigerators. So like an air conditioner like this, it makes a warm room cold. So the heat is taken out of the room to the air conditioning and is given out to the surrounding. So the air conditioning works based on the concept of heat exchanging. And we have power plants in industries like boilers and condensers. They all work based on heat exchange. We have automotive devices like in a car radiator. So a car radiator takes out heat from the car engine and gives it to the surrounding. We have intercoolers. Heat exchangers are applied in chemical and food processing industries, marine aerospace industries, and radiant cooling systems. So as you can see from the diagram here, there's some heat exchange going on in the figure below. So the one colored red is the hot fluid or the heat exchange, and the one colored blue is the cold liquid or something, cold liquid or water, which is the coolant. So when the hot fluid, which is in the pipe, is enters the tube, then the cool liquid flows over it. So it takes out the heat from the red colored substance or the hot liquid and gives it out in the system. So we continue. So these are some various images showing different types of heat exchangers. So like I talked about earlier, classification according to the construction. We have plate heat exchangers. These are some tube heat exchangers, air to air heat exchangers. So this is a type of radiant heat exchange, air to air. So the medium for heat exchange is air or vacuum. We have pure heat exchangers. So these are some various images showing different types of heat exchangers. Now let's talk about the main thing, keeping the main thing. The radiant heat exchanger is a type of heat exchanger that transfers heat primarily through radiation rather than conduction or convection. So as the name implies, radiant heat exchanger, its main mode of heat exchange is radiation. And unlike conventional heat exchangers, they rely on direct contact between fluids. So there must be direct contact between the fluid or solid surfaces, where in such a process, the radiant heat exchanger emits thermal radiation to transfer heat between surfaces at different temperatures. So the mode of heat exchange is the emitting of thermal radiation between the surfaces. So it is often called a hydronic radiant panel, essentially because mainly it uses circulated heated water through pipes embedded in a surface like a floor to transfer heat via radiation. So that's why it's usually called a hydronic radiant panel, meaning that mainly some of the that is mainly used is water, hydronic, as the name implies. Water is a heating medium for the substance. So this is the most common type of radiant heating system where hot water is pumped through pipes to radiate heat directly to surrounding surfaces. So that's basically how the hydronic system works. So let's look at how the radiant heat exchanger works. So on the diagram here, you see a schematic showing the in-detailed view of a radiant heat exchanger. So first of all, in a heat exchanger, the first process that occurs is heat generation. So there must be a high temperature surface. Example, a heated metal plate, combustion chamber wall, or radiant heating element, which emits infrared radiation due to its thermal energy. So the amount of radiation emitted depends on the material's emissivity and temperature. So that's like a black body form of equation. So there must be a heat energy generated in the system. And then in the second process, infrared radiation transfer, there must be transfer of heat between the two mediums. And the modes of heat transfer in the radiant heat exchanger is the radiation process. So the thermal radiation travels in straight lines and does not require air or liquid to carry the heat. Radiation can be reflected, absorbed, or transmitted depending on the surfaces it encounters. So high reflective materials like polished metals reduce heat loss, while dark metal surfaces like ceramics or coatings absorb heat efficiently. So that is the infrared radiation heat transfer. So when you look at the diagram here, for the metal plate, you can see the metal plate in the diagram, the heat absorbing radiation hand. So this is the infrared radiation transfer. This is where the process occurs. And the metal plate, that's the radiation surface. As I'm pointing in the, as you can see from the what I'm showing in the diagram. So then there is heat absorption. So once there is emitting of heat, there must be absorption of heat. So the receiving surface, example, heat exchanger panel, fluid conduit or another material absorbs the radiant energy and converts it into heat. In a fluid, water or oil flows near the absorbing surface. It picks up heat and carries it to another location. So that's the third process that occurs in a radiant heat exchanger. There is heat absorption. One, there is giving out of heat. There must be something receiving the heat. And then it will distribute the heat. Heat distribution. The absorbed heat is transferred to the working medium. That is the air, water, or steam, using a different process, which is not radiation anymore, but conduction or convection. Yeah. In applications like radiant floor heating, heated surfaces like tiles or metal plates warm up the room by radiating heat to objects and people. So basically, most substances we have in our daily setting, or in our, let's say, our our basic living rooms and stuff, they are radiant heat exchanging substances. Because for example, on a hot sunny day, your room feels hot because your roofing sheet gives off heat in a radiant form, which is then transmitted to the room through the medium, that is the fluid, which is air. So you feel hot. So that's basically a radiant heat exchanging type of process. So the components of the radiant heat exchanger, like I showed in the previous slide, we have a hot surface or a heat source. There must be a hot surface or a heat source, something that is going to give off the heat. And there must be emitters and absorbers, the radiant surfaces, designed to maximize heat emission and absorption, often coated with materials that will enhance the radioactive properties. And then inside the radiant heat exchanger too, you can decide to put in a reflector. It is optional, which is used to direct and focus radiant energy more efficiently onto the target surface. So below are some advantages of the radiant heat exchangers. They have high efficiency direct heat transfer, since it doesn't involve too many mediums or any transport fluid. There is high efficiency of direct heat transfer. There is uniform heating, which provides even heat distribution without creating hot or cold spots, and it reduces temperature fluctuations, improving consistency in the process. So there is uniform heating. It's a quiet operation. You won't hear much noise in a radiant heat exchanger, since there are no moving devices or so much working fluid in the system. And it's very versatile, quite versatile. It's easy to handle. You can make changes to the system. It can be used in various applications, and it works very well with renewable energy sources like solar thermal systems, hence enhancing sustainability. Then we look at some disadvantages of the radiant heat exchangers. Basically, let's say because they have a high efficiency direct heat transfer system, they have a high input cost. There's a high initial cost. It's very costly to install such systems, and it involves the use of specialized materials, that is the absorbers and the emitters, and it requires proper placement and design. So if you don't design your radiant heat tube exchanger very well, it can lead to reduction in efficiency, or installation mistakes can lead to overheating or underheating in certain areas, and it's less effective in some environments. And so, like for example, outdoor use limitations. Radiant heat works best in enclosed spaces because there is no external heat exchange or work between the surroundings. Everything is internal. So it works best in enclosed spaces, like a closed system kind of. In open or windy environments, the heat dissipates quickly here. So that's it. When you open a radiant heat tube exchanger to environment, there won't be highly efficient heat transfer because some of the heat will be going out of the system. So that's basically some of the disadvantages of the radiant heat tube exchanger. So we come to the end of this presentation here. Thank you very much for your time.